given in this problem an overall reaction and a mechanism. We are also told that experimentally the rate law is given as this. We're asked from this information to determine which step is the rate determining step. Given here is a mechanism that has two steps. We see them listed there as step 1 and step 2. To determine which of these two steps is the rate determining step, we write the rate law for the steps. And when you write a rate law for an elementary step, you get to use the coefficients of the balanced elementary step, and we have a 1 for A and a 1 for B, as the orders of these substances. So it's first power in 1 and it's first power, in A and first power in B, but we don't write first powers. So let me go ahead and erase those two 1s right there, just so we know that they don't get written in if they're to the first power. For the second step, we know that the rate law would be the rate constant times B times Q. Now we see here that this rate law matches the experimentally determined rate law of the overall reaction. That means that step 1 is determining the rate of the reaction, and we call that the rate determining step, sometimes called the rate limiting step. So we've answered the first question, which step is the rate determining step, and that would be step 1, again because it matches the rate law of the overall reaction. The second question asks if the reaction is catalyzed. To be catalyzed, a substance needs to be added to the reaction that gets consumed as a reactant in an early step and later regenerated. As we look at this reaction, we see that Q does cancel out, and that starts out thinking, well, maybe that could be a catalyst. But catalysts are consumed and then later produced. This substance is produced and later consumed. So we see Q being generated in an early step and getting used up in a later step. That is not a catalyst, that is an intermediate. So Q is the intermediate. And in this reaction, there is no catalyst.